Hello and welcome to the coding notebook. Today we are going to solve another problem with the approach of two pointer. So the problem is container with most water, and this is a medium level question. Before this question, whatever we have solved that was easy level. So we are upgrading ourselves to the higher level with this question. What are the things has been given here? We are given an integer array of height n. So this is the array we have given, and the array is the heights, and numbers of elements are there. There are n numbers of element means n vertical lines 1, 8, such that two endpoints of ith line are I0 and I height. So this is giving us the coordination, x and y coordination. So it will be better if we try to draw a graph and we will understand better. We are going to draw the graph for this array given height. This is going to be our y-axis and this is going to be our x-axis, and the coordination will be like 0 0 here, 1 2 3 4 5 6 7 8. The height will be 1 2 3 4 5 6 7 8. So this is representing our height and this is representing the index number. When we'll draw the line for each element, this is our first element. First element means zeroth index. Zeroth index, the height is 1. The height is 1 means if we draw for our zeroth index, the graph will look like this. This is the height of our first element. For the second element, the height is 8. So we'll draw the line like this. For the second element means let's write the index number here 0, 1, 2, 3, 4, 5, 6, 7, 8. So second element means first index. First index, the height is 8. So here is the 8, the height is 8. Let me draw all the height for each element, then we'll see how it looks like. I have drawn all the lines for each element like 8 for the second element, third element 6, fourth element 5, yeah, here, third element, seventh element 3, and eighth element 7. Now let's see the coordination is satisfying our given question or not. So here the coordination are like for the first element 0 and 1. So here you can see here I means the index number and the height is 1, 0 and 1. Yes, it's satisfying. Now the question is find two lines that together with the x-axis. We have to find out two axes that form a container such that the container contains the most water. First of all, this line. Find two lines that together with the x-axis from a container. Container means what? This is a container, right? This we can consider this as a container. So from this two line, any two line we will consider and we will form a container. So let's consider any two line, this line and this line. Consider this line. Now let's form a container. This will be the container, right? This will be the container. Why this will be the container, not this? Because we are going to pour water. If you pour water, assume that you pour water here. If you pour water, it will fill up like this, like this, like this, until here. After this height, how much you have water pour here, it will goes outside. So this is going to be the container, right? We have to find this kind of container by using any of the two axes, any of the two lines, so that it will hold more water. For example, this two line we have taken, right? This is containing this much water. Then Assume that we have taken these two. These two means what? Up to here the water will hold. Up to here this water will hold. You can see the water is more here. Means container is containing more water than the previous one. So the question is saying this one only. Maximum amount of water can store. We have to return the maximum amount of water. How much water it's containing, how much water it's containing. We have to check and we have to find a maximum amount of water and we will return that. Just think by analyzing the lines, which two lines will make the most water. You can see this one, right? You can see this one is having more height and it looks like it can contain more water, this much water. This much means how much water it's containing, how much water it can contain. To find out that, you can see this is a rectangle, and if we are able to find the area, this is the area, right? This is the area. If we find out the area, then you can easily get how much water it will hold. How much water means the area, width into height. Height we already know, 8. Height is 8. Now width from here to here. How much width? Here to here. 1, 2, 3, 4, 5. So the width is 5. 5 into 8, 40. This amount of water these two lines can hold. Let's consider one more two pair, like this one and this one, and we'll try to calculate how much water it will contain. Now this much water it will contain, right? This is the minimum height. Now the width is 1, 2, 3, 4, 5, 6, 7. 7 is the width. The height, how much height? This much. Because up to here the water can hold. So what is the height? 7. 7 into 7, 49. You can see it is holding more water than this before one. So this is going to be our answer. And in the output also it is saying 49. This is how we are going to identify the most rainwater in a container. Points we have noticed here are, first, how much the height will be when we are taking two lines, like here one lines. What will be the height? Height will be the minimum from this first one and second one. Assume that this is our left one and this is our right one. Okay, the lines, left line and the right lines. So the height will always be minimum from this left and right. First point. Second point, how we are calculating the width in this diagram. Assume that these are the two lines we have taken. What is the width? 1, 2, 3. So here by looking at this, the width is 3. How we are getting 3? Let's take this left. Let's take this right. We are getting this by right minus left. Right is how much? 3. Left is 0. From the x-axis, we are getting 3. 3 is your width. Let's take another 2. Assume that this 3 and this 7. If you normally count 1, 2, 3, 4. So the width is 4. Let's try this formula. Right is 7. Left is right is 7. Left is 3. 7 minus 3, 4. You can see both are matching. So how we are getting width? Right minus left. Okay, this point we have to remember. And the area we have already discussed, height into width or width into height both. These points we have noticed here. If you didn't understand what is happening, let's try a brute force method so that you can easily understand everything. If you understand this, you can skip this part and jump into the pseudocode. What we will think? First of all, we'll take the lines, right? this line we'll calculate the area, how much it will be. We'll keep again, we'll take another two line, again we'll calculate the area and we'll keep, which will be first of all line 1 and line 2. This is height 1 and height 2. Height 1 means this one, height 2 means this one. How much water it will contain? It will contain this much water. The height 1, the width 1, water amount it will contain 1. This is over. Now we will compare the first line with the second one. If you compare with the first and second, again how much water it will hold? This much water, right? This much water means width is now 2 and height is now again 1, because this should be the minimum between these two comparable lines. 2. Now the most water has been updated to 2. Like this, we have to compare with all, and we have to calculate the most water, right? Again, after this first line completed, we'll take the second line. We don't have to compare with the previous one because we have already find out this one, right? It will be the same. When it will be the second line, we'll move to the next. Next means this second line will start with from the next line up to here, right? So when we compare these two, this much of water it will hold. How much? The width is 1. The height is 6. 1 into 6, 6. If it is more than the previous one, then it will update. If it is not more than the previous one, it will not update. Same like, again we will compare these two. So how much water it will contain? This much. Again we are calculating the area and finding out how much water it will contain. So after all the loop, like this one completed, this one completed, this one, when we complete all the lines, we'll get most water container. Two lines, we can find it out. But each and every element we are traversing two times. This one two times, this one two times, this one two times. Each element we are taking as I, we are starting from the I plus 1. So it will take the two loop, right? I from 0 to n and j will from I plus 1. Two loops we need for finding out this answer. So the time complexity big O of n square for this, and space complexity will be big O of 1. We are not using any extra element. Okay. Next, we'll think how we can solve this one with two-pointer. Let's see how we can resolve this question with two-pointer approach. First of all, we have to think which approach is going to work here. Till now, we have no two approaches, left and right, and fast and slow, or slow and fast. In fast and slow method, whatever the question we have resolved, it was like removing element or any rearranging. But the left and right pointer, we have resolved two sum where we have to find two element, and the two element is going to satisfy with the target. It sounds similar with this question. We have to find two lines and we have to find the maximum. So it is going to use this left and right pointer. Let's declare the left and right pointer in our given array of height. So here our left pointer will be, and here our right pointer will be. Let's write here also left and right. We have to form the container and we have to find the area, how much it will hold the water. And we have already discussed how we are going to find the height minimum between the left and right. Okay, minimum between the left and right, how much? 1, 1. And the width will be right minus left. How much right? 7. The left 1. So the right is actually pointing to 8, and the left is pointing to 0 for now. So the width will be 8. Let me write the index so we will not get any confusion. 0, 1, 2, 3, 4, 5, 6, 7, 8. Now the area is 1 into 8 equal to 8. We will declare a maximum where we are going to keep this maximum value. We'll update when we'll get a. Now the step number 1 for finding area for the left and right lines has been completed. For this step number 2, we have to move the pointer, right? Either the left or the right. So how do we get to know which pointer we have to move for this? This is not a sorted array so that we can move the left one to finding the bigger value, right? Let's try by moving both the pointer one by one and we'll see the results. Suppose we have moved the right pointer to here. So the right pointer will be here for this. Even though we move this right pointer, the height will be same because the minimum height is left. Height is same because we are always considering the minimum and the minimum is left. Height is 1. Only the width has been changed. Change also decreased. Before it was 8, now it is 7. So the answer will be 7 when we move the right pointer. Let's try to move the left pointer and we'll see what result it will give. When we move the left pointer, this is when we move the right one. This is when we move the left one. When we move the left pointer, the height is increased. You can see the height is now 8 and the right is 7. So the minimum will be 7. Height will be 7. Okay. And the width will be how much? 7. The answer will become 49. Okay. One thing you may notice here that if we have two pointer, okay, assume that these pointers are here. Smaller minimum height is right one. And if we move this left one, always you have to consider this smaller height. For example, we have taken this one and we move this right pointer to here. Still the height is same. Again we move the right pointer. Still the height will be same. And also it's decreasing the width. So whenever we are having two pointer left and right and we are having a minimum between these two, any of the, it can be left or it can be right. So minimum is getting fixed and whenever we are moving the other pointer, the width will again decrease and we'll get a less number value from the last result. So the conclusion is here, whenever we have two pointers left and right and we have done with the operation, what we have to do? We have to move the short pointers. Why we have to move the short pointer? So that we can get more value. It can be more, it can be less, but there is a chance of getting more. But if you move the higher value and keeping the smaller one, it always be less. That's why the second step is move the pointer pointing to the shorter line. Because we have seen whenever we are moving a shorter line, the area may increase. But if we move a higher line, the area always decrease. That's why move the pointer pointing to the shorter line. Let's do a complete dry run for this array and you will get it better. Let's declare the left and right pointer and we have to declare a maximum so that we can update it. Now we are going to find out the area. Area will be first left and right pointer. The area will be how much? The minimum between 7 and 1, 1. 1 into the width. Let's write this 3, 4, 5, 6, 7, 8. The index so that we can get it better. 8 minus 0. How much? 8. 1 into 8, 8. Update this maximum container. Now, the second step we have already discussed. We have to move the shorter line. So the shorter line is which one? This one. The left will come to here. The area will become now for this first one, second area. Area will become how much? What is the minimum between these two? 7. And the length is, and the width is 8 minus 1, 7. 7 into 7, 49. Let's update this into 49. 49. Again, we have to move the shorter array, shorter line. So in between these two, the shorter line is this one. So we will move this inward, right. Now let's calculate the area for the third area. 3 and 8. What is the minimum? 3. And the length? 7 minus 1. 3 into 6, 18. So this is not going to update because maximum is still there. Again, we'll move which is shorter, this one. We'll move the right pointer to here. Now the area will become, what is the minimum? 8 only. And what will be the width? 6 minus 1, 5. 8 into 5, 40. 40 is still less than the maximum, so maximum will not get update. Now fifth time. We are going to move any of these, we can move because both are same. So let's move this right one only. Right. The area will become, which is the minimum? 4. The length and the width, 4 minus 1, 3. 4 into 3 equal to 12. And the next area here will be the right. Now 5 is the minimum and the length is 4 minus 1. This I made mistake here. This will be 5 minus 1. 5 minus 1, 4, 16. Here 4 minus 1, 3, 15. Still it is not going to update it. Again we will move the right to here. When we moved and the minimum became 2, right? 2 is the minimum between this one. This 8 and 2. 2 is minimum. And what is the length? 3 minus 1. How much? 2. 2 into 2 equal to 4. Maximum is still there. Again, we are going to move the right one only because right one having the shorter length here. Now the area will become 8 into, sorry, 6 into, because 6 is the minimum, 6 into 1. The length is 1. 6 into 1, 6. The maximum will still there. And whenever they cross each other, that means left is less than right. This is going to be our loop condition. Until left is less than right, we have to do this. And finally, we got our answer. That is the 49. We already see in this example, the answer is going to be 49. This is our desired answer and we got our answer. Let's jump into the Java solution for this one. We are having a method max area and we are given with a height of array. Now we'll declare the left and right pointer. The left is going to start with 0 and the right and minus 1. So n is the size. We can take here n equal to height dot length. Again we have to declare one more variable, maximum area, where we are going to keep our maximum value. Let's keep it as 0. Now as per our condition, we are going to start the loop while left is less than right. Here we are having two cases. First case, when the left height is less than right, then we have to move the left pointer And second case, when right is less than left, we have to move the right pointer. Okay, this we have already discussed. So this is the moving shorter line. First of all, we'll calculate the area. First of all, we'll find out the height and width. Integer height is how much? Minimum between left and right. And width is right minus left. Now the area. Integer area equal to height into width. And we are going to compare this area with our maximum value and we will update the maximum value. So maximum area will become maximum of maximum and area. What will be the maximum between this current maximum and the area, that will be going to update here. Now our cases we have written here, right? How this pointer is going to increase. If height of left less than height of right, then we are going to move the left because left is smaller. Left plus plus. Else we can directly move. Else means what? Else means right height less than left height. When the right height is less, we are going to move the right one, right minus minus. In the end, we'll just return the maximum area that we have declared. So this is our solution for this particular question. You can see how easy it is, but just you have to understand the question and which approach we have to apply, we have to figure out. And the time complexity for this will be big O of n and space complexity will be big O of 1 within this any space, and we have only iterate each element for one time. I am listing out some similar question. You can go and try to resolve it. Leetcode 42. Trapping rainwater. Next one is boat to save people. Next one is Leetcode 977. This is square of a sorted array. Try this by your own. Later we will solve this question.